This is Peter with CalcBook, and today we're going to do a structural wide flange design. So we'll go ahead and open up CalcBook. We're going to go ahead and select our steel module, and we're going to go straight into the steel member design. And when we click on that, we have a few options here. We're going to go ahead and start with a Chapter E compression, and we're going to open up the Chapter F flexural design about the major axis. So we'll go ahead and select our shape, right? We have the option of doing a standard shape or a custom shape. Today we're just going to do a standard shape. So we're going to go with the wide flange. And we're going to select a W10, let's see, W10 by 15. You can see it's already starting to populate the geometric properties that we're going to need for the design. And it's already populated the appropriate material design values for this type of section. So we'll go ahead and click on our Chapter E compression design. Right, we're going to enter our buckling lengths. You can do x-axis, y-axis, and then you also have the option of turning on the check for torsional and flexural torsional buckling. And along with all these factors here as well, there are some tooltips here if you need them, just to help you refresh your memory on what you need for the effective length factor, or if you want some more information on the torsional and flexural torsional buckling, there's some information here with references to the code. But we're going to go ahead and assume today that our unbraced length is going to be 10 feet above the X and the Y. And you see here, we've already got it. It's in AISC right now with the 1.67 omega, but we're going to go ahead and switch that over to LRFD. And then we're going to go over to our demand. You have the option of basic load combos, advanced load combos, or none. Sometimes if you're using an analysis model, you already have the factored loads you want to input. So we'll go ahead and do that today. We're going to say we have a load of an ultimate load of 25 kips. And you can see before we get into the details, right, it's already given us our capacity and our demand and our DC ratio for this section. But we can go ahead and pop in our compressive demand, which is just going to show our ultimate load. And then it'll go through and do the design per the code check. So it'll check the flange, right? In this case, our flange is non-slender. It'll check the web. And in this case, actually, our web is slender. And it's got some associated images and references as well for all of these items. Then we can jump into the details of the calculation, right? Our limiting slenderness ratio. In this case, it's about the y-axis, right? Our y-axis controls. We go into our flexural elastic buckling stress, our controlling buckling stress. If we had flexural torsional buckling clicked, it would figure out which of those it controls, but in this case we don't, so it's just our flexural buckling stress that controls. And since we did have a slender element, it does go into the E7 chapter to determine if any reduction in area is required. In this case it's not, so we just use our gross area for this section. And then finally our design compressive strength. So now that our compression design is done, we can go over and click over to the Chapter F tab. And for this, all we need to enter is our laterally unbraced length for flexure. So for this, we're going to say this is a completely unbraced beam. So we're going to go ahead and enter in the same distance we did for the column length at 10 feet. And then you can adjust your LTB factor CB, but we're going to leave that at 1. And if you have any questions on the lateral unbraced length, there is another tooltip here if you want to see what that is referencing. So if we go back to the top here, right, it's going to run through similar checks now for flexure, right? So it's going to go to the spec table B 4.1b and then run through the checks for that as well. So in this case, our flange is compact, the web is compact, and so it'll run through the checks for just your nominal flexural length for yielding, and then for lateral torsional buckling, and it'll run through all the steps and the code checks for that, and finally give you your design flexural strength. We do need to enter our design loads, so we'll go ahead and again we have our information coming from a model that we did. So for this, we're going to say that our moment here is going to be 55 kip feet, right, which is exceeding our section capacity here. And we'll come back to that in a second, but I want to show that it's already populated the Chapter H combined loading. And so here you can see it's got the values from our previous calculations, and it will put together the appropriate combined loading section from Chapter H. And we're pretty far over capacity here. So we're going to go back to our member properties. We're going to keep a W10 section. We're going to go up to, let's see, a W10 by 60. And let's see if that works out. So that puts it down much lower to 0.22, and so we're okay there. So that's our design for the wide section, and stay tuned for more.